Hey everyone, welcome to the blockchain and cryptocurrency course. In this tutorial, we will be learning about proof of work, in which we will cover what is proof of work, how mathematical puzzles come into picture when using proof of work, how you can implement proof of work on blockchain, why not to use other algorithm instead of proof of work in Bitcoin blockchain, and at last what are the flaws in proof of work consensus algorithm. So there are a lot of things to learn in this tutorial. Let's get started. Proof of work or POW is the original consensus algorithm in Bitcoin blockchain network. Proof of work is one of the steps to mining Bitcoins. We will see more about mining in other video. In blockchain, the algorithm is used to confirm the transaction and produce new blocks to the chain. With proof of work, miners compete against each other to complete the transaction on the network and to get rewarded. In network, users send each other digital tokens or coins. A decentralized ledger gathers all the transaction into blocks. However, care should be taken to confirm the transaction and arrange blocks. This responsibility bears an special nodes called miners, and a process is called mining. The main working principles are a complicated mathematical puzzle and possibility to prove the solution. The mathematical puzzle. In proof of work, it's an issue that requires a lot of computational power to solve mathematical puzzle. When transaction is broadcasted to nodes, every node is given a challenge and they need to come up with some response. After they have a proof, they need to apply a hash function to challenge and proof to obtain final hash. Normally final hash contains first large number of bits 30 to 40 bits 0. If miner or node gets the hash, then they can add block to chain and they are rewarded with bitcoins. It is hard to obtain a hash without proof response, but it's not impossible. If you try brute force, you may get a solution, but it's very expensive. The answer to the proof of work problem or mathematical equation is called hash. As the network is growing, it is facing more and more difficulties. The algorithm needs more and more hash power to solve. So the complexity of the task is sensitive issue. But the problem shouldn't be too complicated. If block generation takes a lot of time, the transactions are stuck without execution, and as a result, the workflow hangs for some time. If the problem cannot be solved in definite time frame, block generation will be kind of miracle. But if problem is too easy, then it's prone to vulnerabilities, DDoS attacks and spam. The solution needs to be easily checked. Otherwise, all nodes are capable of analyzing if the calculations are correct. Then you will have to trust other nodes, and it violates one of the most important features of blockchain called transparency. Implementation on blockchain. We have already seen how proof of work is implemented. Miners solve the puzzle from the new block and confirms the transactions. How complex a puzzle depends on the number of users, the current power and network load. Each block contains the hash of previous blocks, which increases the security and prevents any block violation. If a miner manages to solve the puzzle, the new block is formed. The transactions are placed in this block and considered confirmed. The puzzle is hash cache. This algorithm allows changing the complexity of puzzle based on the total power of network. The average time of block formation is 10 minutes. Bitcoin-based cryptocurrencies such as Litecoin have similar kind of system. So this is how proof of work is implemented on blockchain. But why proof of work? The main benefits are the anti-DDoS attack defense and low impact of stake on mining possibilities. Defense from DDoS attack, proof of work imposes some limits on action in network. They need a lot of efforts to be executed. Efficient attacks requires a lot of computational power and lot of time to do calculations. Therefore, the attack is possible but kind of useless since the costs are too high. Mining possibilities. It doesn't matter how much money you have in your wallet, what matters is to have a large computational power to solve the puzzle and form new blocks. Thus, the holder of huge amount of money are not in charge of making decisions for entire network. Flaws in proof of work. The main disadvantage are huge expenditures, uselessness of computation and 51% attack. Huge expenditures. Mining requires highly specialized computer hardware to run complicated algorithms. The costs are unmanageable, so mining is becoming available only for special mining pools. These specialized machines consume large amount of power to run it, and that increases the cost. Large costs threaten centralization of the system since its benefit. It's easy to see in this case of Bitcoin. A 51% attack or a majority attack is a case when user or group of users control the majority of mining power. The attackers get enough power to control most of events in network. They can monopolize generating new blocks and receive reward since they are able to prevent other miners from completing blocks. If group of people have 51% of power, they can reverse transaction. Let's assume Alice sent Bob some money using blockchain. Alice involved in 51% attack case. Bob is not. This transaction is placed in block, but the attackers don't let the money to be transferred. So this is how 51% attack is danger. Basically, it's a centralization of a network. So guys, let's quickly revise what we have seen in this tutorial. We have learned what is proof of work, how mathematical puzzle works in proof of work, how proof of work is implemented in Bitcoin, why proof of work and not any other algorithm, what are the danger and flaws of proof of work algorithm. So this was all about proof of work in Bitcoin. We will keep learning about Bitcoin. Stay tuned for more videos. Thank you very much.